So in this video, we are going to continue with terms used to express concentration of solutions. In the last video, we did this one. We did molarity. And remember, molarity was big M equals moles of solute over liters of solution. But in this video, we are going to do something else, and it's one of my most favorite terms for expressing concentration of solutions, ppm. And ppm stands for parts per million. And the interesting thing about parts per million is this. If you own your own home, you will get a letter in the mail from your local water board. And it will be pretty intense. It'll look like this. And it'll have all sorts of things. Copper ions, chloride ions, lead ions, everything here. And it will be expressed in parts per million or parts per billion. But in high school chemistry, we'll mainly go over parts per million. And I'm going to show you how to do some of these right now. So the formula for parts per million is pretty interesting. It's grams of solute over, most of the time it's grams of groundwater. And then it's times a million. So this is going to be ppm or parts per million. If you wanted to do parts per billion, it would be the same formula, only adding 3 more zeros over here to get parts per billion. All right? Now, so what we're going to find right now, and then we'll find out how many ppms there are for the water that was in 25% of the households in Flint, Michigan. But the first thing we have to find is what the EPA standard for lead ions in water is. So we're going to find ppm, and what they give us is 1.5 times 10 to the minus 5 grams over 1 liter of groundwater times 1 million. So this is the formula. So we have to take that out of scientific notation and figure out how many grams of water are in 1 liter of water. And then we'll be able to figure out what the EPA standard is in parts per million for lead ions. Okay, so the first thing is we've got to take this out of scientific notation. So once again, it would be ppm equals, there'll be 4 zeros there, 0.12345 grams. And then 1 liter, well, if you remember, 1 milliliter of water weighs 1 gram. So if I have 1 liter, that's 1,000 milliliters. And 1,000 milliliters would equal 1,000 grams of water. Now we multiply it by 1,000, a million. Now, we could go this number times 1,000,000 divided by 1,000 in your calculator. But I like to knock off as many zeros as possible. So let's do it. So if we have 3 zeros down here, we knock those 3 off with these 3 zeros. And then this number times 1,000, all we have to do is move this decimal place 3 places to the right. 1, 2, 3, right there. So now we find out that the parts per million of lead ions is 0.015. 0.015. And that is the maximum amount of lead ions in parts per million that water should have in it in order to drink it. Okay? So we're going to put this, which is the EPA standard, over in that corner, and now we're going to figure out something about Flint, Michigan's water. So there's the EPA standard for lead ions in water is 0.015 parts per million. Now, we are going to figure out how many parts per million 25% of the households in Flint, Michigan, I don't know, it was 8 or 10 years ago, had when they changed their water source. Okay? All right, so now what we have is this. We're going to go ppm equals, this is what they found in their water, 1.32 times 10 to the negative 2 grams of lead ions in 1,000 grams of water times 1 million. Okay, now, remember, this is the amount of lead ions they found in 1 liter of water. So we're going to find the ppm, and then we're going to see what it is compared to the EPA standard. So let's do this. We have 1, 2, 3, 1, 2, 3, and now we have to take this and take this out of scientific notation. So we're going to move the decimal place 2 places over. So it's going to go 1, 2, so it's going to be 0.0132, okay? And we're going to wipe this out because we just did that. Okay, so now that's out of scientific notation. And now all we have to do is multiply that number by 1,000 or move the decimal place 3 places over, which is 1, 2, 3. So now we have the ppm of lead ions in 25% of the households in Flint, Michigan. It was 13.2. So the ppm is 13.2. Now, look, this is the maximum limit of ppms the EPA says for lead ions in water. Look at this. This is 13.2. 13.2, that's hundreds and hundreds of times more lead ions in the water than the EPA standard. So, would you drink that water? Absolutely not. And it made many, many people sick. So this was in 25% of the households in Flint, Michigan. Okay? So that's what ppm is used for. Parts per million is used to figure out what is in the water and how much is it, and then they compare it to the EPA standards to make sure you're drinking water safe. All right? So let's do a few more. In this question, since we found ppms, we're going to find grams. So we have to give ppms in a certain amount of groundwater. So here we go. Okay. So a substance has a ppm of 350 in 10,000 grams of groundwater. And now we just got to find out, this would be for copper ions. So let's do it. So I have the ppms at 350, so we go 350 equals. We're trying to find out the grams of copper ions, so X grams. And we know that it's in 10,000 grams of groundwater. And once again, times a million. Okay, so what we have to do is this. We can knock off 1, 2, 3, 4 with 1, 2, 3, 4. So now we have 100x equals 350. So now all we have to do is take the 100, put it over here, so 350 by 100, and that'll give us how many grams of copper ions there would be. So we knock off those two zeros and we divide 35 by 10. So your answer for this would be 3.5 grams. So that would be 3.5 grams up here, 3.5 grams of copper ions in 10,000 grams of groundwater and a ppm of 350. Okay, let's do another. Okay, so here's another problem. What is the ppm if 20 grams of Na2S is dissolved in 40,000 grams of solution or groundwater, whatever you want to call it? So let's set it up. ppm equals grams on top, 20 grams, grams on the bottom, 40,000 times a million. All right, so you can put it in your calculator, but like I said before, I knock off zeros, so we have 1, 2, 3, 4 zeros, 1, 2, 3, 4 zeros. So now what we have to do is it would be, we could go 20 divided by 4, that's 5 times 100. So this would equal 500. ppm equals 500. So one more time, if we do this, we could do it a whole bunch of different ways. We could go 20 times 100. So if we do 20 times 100, it would be 2,000 divided by 4. So that would be 2,000 divided by 4, and that would be 500. Okay, either way we do it, that's how you get it, and your answer is 500 ppms. Okay, find grams of chlorine ions if the ppm is 15 in 50,000 grams of groundwater. Set it up. I know my ppms is 15. I'm looking for X grams of chlorine ions. And I have 50,000 on the bottom times 1 million. Okay, so 1, 2, 3, 4, 1, 2, 3, 4. So now what I have is I have 100x over there, and then this would be 15 times 5. And that will be 75 equals 100x. 75 equals 100x. To get x by itself, I simply dump the 100 underneath there. So 75 divided by 100, and that is this. 0.75 grams of Cl minus ions. So that would be your answer, 0.75 grams of Cl minus ions. It would go right here. All right, so whichever way you prefer to do ppms, but be careful of all the zeros, especially using it in your calculators. The final question in ppms, we found ppms, we found the grams on top. Now we're going to find out the grams on the bottom. This is the most difficult one because students hate when an unknown is in the denominator. So we're going to do it right now. So of all this, find the grams of solution needed to produce ppm of 50 by having 8.4 times 10 to the minus 2 grams of iron ions in that solution. So we're going to go 50 equals on top change this to out of scientific notation, 0.084 grams. And this is going to be X grams times a million. Okay, so now we're looking at this, and what we have to do is multiply that by that. So this is going to be 50x equals, and then we're going to use 0.084 times a million. So we have to move the decimal place that 6 times that way. 1, 2, 3, and then 3 zeros. 8, 4, 1, 2, 3. So this 50x equals 84,000. All right, so now x equals 84,000 divided by 50. Knock those zeros off. So that would be 8,400 divided by 5. And that would be 1,700 grams of solution. That is your answer. So one more time, if x is in the denominator, multiply it by the ppm. That's how we got 50x. And then multiply a million times 0.084 in your calculator, or just the decimal points. That'll give you 84,000. 84,000 divided by 50 is 1,700 grams of solution. So we've gone over how to find ppm, how to find grams of solute on top, and how to find grams of solution or groundwater on the bottom. Hopefully this helps you do ppms.